Big data can be used for forecasting demand in different areas, including seasonality, weather, and search engine queries and web traffic. Forecasting short-term demand is crucial for hotels, and these data points can significantly affect demand. Based on several studies done, there is much correlation between weather and demand at hotels. Weather conditions such as rain, snow, sunshine, and higher low temperatures can affect demand depending on the location. For example, we can see with historical data that an increase in snowfall at a ski resort will increase demand. Search queries and web traffic can also predict demand. By analyzing the amount of times a website is visited, firms can predict demand as more visits are correlated with more bookings. Lastly, big data can also be used to analyze customer profiles and predict their behaviors based on preferences and demographics. All of this combined leads to hotels using big data to guide strategic decisions to lower costs and increase revenues. As a result of utilizing big data in the form of pricing algorithms and demand forecasting, high revenues can be achieved, thus increasing RevPAR, or revenue per available room. The calculation of RevPAR is simply taking the room revenue divided by the total number of rooms available in a given hotel or group of hotels. RevPAR is an important performance measurement tool in the hospitality industry that analysts use to measure performance of a publicly traded hospitality company such as Marriott or Hilton. RevPAR is published in quarterly reports and tells investors how strong the firm is performing. Previous methods used for analyzing data included time series models, econometric models, and other tools such as classification or regression. Big data complements traditional data methods by collecting this mass amount of data and performing multiple traditional algorithms together to perform a more powerful and more insightful analysis. So where does this big data come from? It comes from various sources, including reservations, offer redemptions, social media, bookings, reviews, surveys, and much more. We will discuss 3 specific examples in the hotel industry to show what they are using big data for and how they are analyzing big data. Our first example is Hotels.com, which is part of Expedia and uses Apache Spark to tailor image content and hotel listings to the specific user. Use cases of Spark involve detection of hotel photos that are potentially duplicates, classification of photos according to what they show, such as the lobby or the pool, and seeing how the images are ranked in galleries. Future work will allow the company to offer highly personalized results and on-screen presentation to each customer based on their preferences. Matt Fryer, their Chief Data Science Officer, says that they are now able to build feedback loops to mesh deep learning with click behaviors and customer behaviors in Spark. Hotels.com chose Spark over Hadoop due to performance benefits. Spark offered better scalability and performance in a clustered environment. Another example is Airbnb. Airbnb has implemented 2 machine learning models to increase revenue and match hosts to guests. First machine learning model tool is a pricing algorithm based on an open source machine learning tool, Aerosolve. This model predicts the likelihood of a lodging listing getting booked on a certain day at a certain price based on factors like demand, listing location, type, and quality. Airbnb can then use this model to recommend how much hosts should charge every night for their listings on its website. There is a user interface component for hosts, which allows them to tell Airbnb the minimum and maximum price they are willing to have their listings booked. However, Airbnb has the option to automatically adjust the prices for the hosts if desired. The second machine learning model created by Airbnb predicts the likelihood of a host accepting a visitor's accommodation inquiry. The model associates hosts' prior acceptance and decline decisions by factors such as check-in and check-out date, number of nights and visitors, lead-in days for check-in, and other factors. The model learns from the behavior or past decisions of hosts to predict their future decisions. For instance, if a host receives an accommodation inquiry like 2-week stay starting on a weekend, what is the probability this host is going to accept the inquiry?